Miss B explains how to balance a chemical equation. Hey guys. All right, first things first, there are a lot of numbers involved with this whole thing. Besides having to write the formulas correctly and everything, you got to get the numbers right. It's kind of like a numbers game kind of deal. Anyway, let me give you a little graphic. Please take notes. Okay, so numbers with formulas. Hooray! All right, these numbers all represent something. The first one, put down coefficients, show relative amounts of reactants or products in a balanced chemical equation. For example, that big 3 in front of the NaOH, that's a coefficient. Kind of like in math, you put a number in front of something and it multiplies everything in it. Subscripts, they show the number of each type of atom in a formula. For example, H2O, that means you have 2 hydrogen atoms and 1 oxygen atom. Superscripts show the amount and type of charge on an ion. For example, with sulfate, SO4, it's a polyatomic ion, and the whole ion has a charge of -2 or 2 negative, however you want to place it. And then there's a potassium ion with a charge of +1. All right, so now basics. You have reactants and products. The reactants are your starting materials, compounds that combine. The arrow means reacts to form or it means yields. And your products are your results, the compounds produced from the combination of these reactants. Compounds are written using the correct subscripts. You can't change the subscripts and stuff. You really need to have them written correctly before you attempt to balance an equation. So let's look at how to do it. I would write this list down if I were you. Hint, oh, hint, hint. How to balance an equation. Write the correct unbalanced equation. Count the atoms of the elements on each side of the equation. If they're equal, the equation is balanced. If not, determine the lowest common multiple. Place the coefficient in front of the compound or element. Count the atoms after multiplying the numbers of atoms with coefficients. If they all equal on both sides, it's balanced. If not, try again. And please be patient. It's a trial and error kind of deal. Okay, let's look at problem 1. Ammonia plus oxygen yield nitrogen monoxide plus water plus heat. First, you write the unbalanced equation, which is right there. And then you count the number of atoms of each element on each side. And you see I have 1 nitrogen, 3 hydrogens, 2 oxygens. Then look on this other side and you have 1 nitrogen, and then you have a total of 2 oxygens, and then you have 2 hydrogens, which means that's not balanced. Okay, you see where we kind of go off the rails there? It's not balanced. Are the numbers of each atom on each element the same on each side of the equation? No, they're not. So let's determine the correct coefficients. All right. Sometimes getting the correct coefficients is a trial and error process. And so we're going to do a little trial and error right here. Okay. I'm going to write the equation again right quick. Ah, darn. Okay. All right, so I got it. Now that I got it, let's do some balancing. All right, N equals 1, H equals 2, and then O equals 1 O from there, and 1 O from there, and that gives me my whole total of 2. All right, so I know I'm going to have to do these. I know they got to be done. And so the multiple between these H's would be 6. So now to get this to be 6, I'd have to multiply it by 3. To get this to be 6, I have to multiply it by 2. So if I do that, then I'm going to have to to multiply this h by 2, I'm going to have to put a 2 in front of the whole thing, because now they're a pair, kind of like a married couple. Now they're a pair, so you have to put a 2 in front of the whole thing. If I do that, now that's going to give me 6, and that's going to give me 2 of those. All right, so now on this side, if I multiply this by 3, that's going to give me 6. So now I have to put a 3 in front of the whole thing, and that's going to multiply. That's going to multiply this one by 3.